Hello everyone, welcome to Algebra 1 with Miss Betsy. I'm so glad you're with us today. We are going to be discussing how you deal with absolute value inequalities. And the text that I'm using for this lecture is Algebra 1 for Christian Schools. It's published by Bob Jones University Press. If you're following along with us in that text, we are in section 5.7 on page 204. If you're not using that same text, it's no biggie. You solve absolute value inequalities the same way. This just happens to be the text that I'm using. Now before we get started, I wonder if you could tell me what it is that you would use with a pig who had a rash. Well, you would put ointment on him, of course, so that he would feel better. So, here's an example of an absolute value inequality. This says the absolute value of x is less than 5. We know that since we have less than, here there are going to be any number of values that will make this to be a true statement. So we're going to be having a solid line somewhere on this graph that shows us a range of values that make this a true statement. But before we even think about that, let's just think just for a moment what it is that absolute value actually is telling us. Well, we learned a number of weeks ago that absolute value is always positive because absolute value is not really a number, but it's more of the idea of a distance. So let's say if where I'm standing here represents 0 on the number line. I can turn in this direction and I can go 1, 2, 3, 4, 5 steps. So I'm now nearly out of the video, but I've gone 5 steps from my starting point. Back in the video now, and I can do a 180-degree turn, and I can go 1, 2, 3, 4, 5 steps out of the video in the opposite direction. Just as if I were going to the right on the number line, turning around and going to the left on the number line. Now, did I take -5 steps? No, there is no such thing. I covered a distance of 5 tiny little steps in either direction. And we saw that that's exactly what absolute value is. Absolute value refers to the distance the number or the expression is from 0. So what this is really saying is that the distance from 0 has to be less than 5 units. So what does that mean? It means exactly this. This is 1 unit from 0, 2, 3, 4, the whole way up to, but not quite at 5 units. All of this in here, these are less than 5 units from 0. We also have all of these negative numbers here, -1, -2, -3, -4, -4.999999999. All of these, the distance from 0 is less than 5. So what we have represented here for all of the possible values of our variable x that would make this to be true can't be -5 itself, because 5, it says we have to be less than 5 units from 0 on the number line. So what does this tell us? This tells us that x has to be greater than -5, and x has to be less than a +5. Now, what can we do with this? X has to be greater than a -5, and it has to be less than a -5, because what happens if x is greater than -5? Remember, we've got negative numbers. For example, it could be -4. That's 4 units from 0, so the distance is less than 5, or the absolute value is less than 5. X has to be less than 5. What if x is 1? Well, it's certainly less than 5 units from 0. What if we said over here if x was 6? Well, we're 6 units from 0 on the number line. The absolute value of that is 6. but we have to be less than 5. So what we have here is a conjunction. We have two statements that have to be true at the same time. It's a conjunction. And we learned in section 5.5 that conjunctions were statements that were joined by an and. Both of them had to be true, so they represented intersection, and from set notation there's sort of like an arch that represents intersection, but we saw that this caret here, or that sort of like a mountain looking thing, that this represents intersection or and. So we could say that x has to be both greater than -5 and x has to be less than 5. And we can combine this, we have to be able to combine this into one statement that tells us that it has to meet both of these conditions. So how can we do this with an x? Well, just think of it this way. Just going to show you a picture. You have this conjunction, looks like a barbell. Think of Mr. X sitting right here, or standing right here, in the middle of the barbell, and he's pumping iron. X has to be greater than -5 and less than +5 at the same time. This statement here is exactly what you use to represent this picture on the number line. I'm going to take a second and walk up here and make sure that that video is showing, because I would be really sad to do this video and have you guys say, "Hey, Miss Betsy, it's not on the board." -5 is less than x, which is less than 5. See here, -5 is smaller than x. X has to be smaller than a +5. Now look, we changed the direction of the inequality symbol, but look, x is greater than -5. If we start here, we can read that the same way. X is greater than a -5. But this is the formula that you have to use. You start with the smallest number, -5 is less than x. X is less than a +5. So when you have this expression right here, when you have the less than symbol or the less than or equal symbol, we are talking about a conjunction. A conjunction is the union. A conjunction is the intersection. It has to meet both requirements at the same time. And it's going to have and it's going to be, the symbol for that is going to be like that mountain top right here. That means and. When you have an absolute value inequality that uses less than or equal to, it is a conjunction. Conjunctions are and statements, two statements connected by an and. Both of those must be true. You see our picture here. X is both greater than a -5 and less than a +5 at the same time. And to help you know how to write the mathematical sentence that represents this picture here, you put the X, he's the strong man in the middle, pumping iron. -5 is less than x, which is less than 5. You can also think here that x is greater than -5, it's less than 5. X is greater than -5, x is less than -5. X is greater than -5, x is less than +5. So think about what absolute value is actually talking about. It's talking about the distance from 0. So here, this tells you the distance from 0 has to be less than 5. So that helps you with an understanding of where you get this barbell-like picture here. So let's look at another example. And that was actually example 2. In example 1, they're just going through some explaining and teaching of how you actually arrive at the theory behind absolute value inequalities that allow you to graph it. I want you to go ahead and read that on your own, do your best to understand it. But let's just think about the absolute value of x is less than 3. And see what happens here. We have the absolute value of x is less than 3. So let me just go ahead and put in our 3, our -3, and our 0 on our number line. And remember, what is absolute value? Absolute value is the distance from 0 on the number line. What does this tell us? It tells us that this absolute value has to be less than 3. Let's change it just a little bit. Less than or equal to 3. Now once you get an absolute value over 3, that's not what we're looking for. The distance from 0 has to be less than or equal to 3 units. Well, less than or equal to 3 units from 0 in the positive direction is that. Our solid circle here indicates the equals. Well, that's just really strange. 3 units in the negative direction, 3 units in the positive direction, and anything in between those. Because we have the less than symbol, it's a conjunction. Conjunction means that you have to meet 2 statements at the same time. What do you have? You have x has to be greater than -3, and at the same time, x has to be less than or equal to 3, less than or equal to a -3. We can replace that and with the upside down caret. This picture looks like a barbell. X is in the middle. He's bigger than this number on the left, but it's not just less than or equal. Less than is less than or equal to. So here, x is greater than or equal to a -3. When we turned around the order, with inequalities, if you start reading at the x, you'll make sure that you're doing things right. Here, this says x greater than or equal to a -3. Here, if you start reading with the x, we have x greater than or equal to a -3. So you see that it's still a true statement. So we have -3 is less than x, and x is less than 3. Less than or equal to 3. That's our solution, and we saw that it was a conjunction when you have less than or less than or equal to. Conjunction with less than or less than or equal to. Memorize this. Make sure that you understand what a conjunction means. You have this barbell picture. You have to meet both conditions at the same time. You can condense, not only can you condense your 2 statements here into one, but you must write it as, this is what they call a compound inequality. 2 sentences at the same time. Compound inequality. -3 is less than or equal to x, and x is less than or equal to 3. You can combine it together just as you do as you create a compound sentence in English. This was with less than or less than or equal to. So let's see what happens if we go from having less than to a greater than inequality statement. Example 3 says, let's look at the absolute value of x is greater than 1. Absolute value of x has to be greater than 1. Back to our definition of absolute value. Absolute value is the distance from 0 of a number on the number line. Here, I guess I do need to put my absolute value bars in there. This says the absolute value of x, or the distance from 0, has to be greater than 1. That means not until you get out here to the right of 1. I don't include the 1 because it doesn't say greater than or equal. It just says greater than 1. 2, 3, 4, 5, 9 bazillion. All of those values there are greater than 1. Well, what are we going to have in this opposite direction? Absolute value. Absolute value is the distance from 0 on the number line. So right here at -1, that distance is 1. We cannot use that because we don't have the equal sign. But over here, -2, -3, -9 bazillion, all of those distances are greater than 1. So this is what we have. This says as long as either this condition is correct or this condition is correct, the entire inequality here is true. So what we have, either this or this, remember that's a disjunction. We use or is where we have union in set notation. As long as it's in either one place or the other place that's a part of the solution, they're going to use sort of a V-looking symbol to represent that. And you're going to write two inequalities here. Either x has to be less than -1 or x has to be greater than +1. There's no way that you can combine these two inequalities into a compound inequality because they don't overlap. Only one of them can be true at once. So this is what you do. Disjunctions, they're going in opposite directions. You can only have one of those conditions be true at once. And this is what we're going to use with greater than as well as greater than or equal to. Disjunctions go in either direction. They have two inequalities that you cannot combine. Conjunctions are less than. They're an overlap and you have the barbell. So let's go ahead and do two more examples. Absolute value of x plus 5 is less than or equal to 10. Absolute value of x plus 5 is less than or equal to 10. So now let's think just a minute first. When we have an expression in here, we're going to have to solve this now, aren't we? What are we going to do? This value has to be less than or equal to 10 units away from 0. So whatever this value is here, have a distance of 10 in the positive direction and a distance of 10 in the negative direction. So this is what you do first. You have to take what is inside the absolute value bars because that expression there has to be less than or equal to a positive 10 units. Units toward the right of 0. Or that same expression can be, let me make sure that I'm speaking correctly. Or it has to be greater than or equal to a -10. A And how did I know that it was going to be greater than or equal to a negative 10? Let me go ahead and put this number line back in here. And let's just go ahead and put the negative 10 and positive 10, even though those aren't the true numbers that we're going to graph. But if the distance has to be 10 or less, you're going to have whatever's on this side, it's going to be greater than negative 10, isn't it? Negative 10, negative 9, negative 8. Whatever's on this side here is less than or equal to 10, isn't it? So that's where we get the x plus 5 less than or equal to 10, or x plus 5 greater than or equal to a negative 10. And what we did with our last example, where it was just the absolute value of x, less than 5, that was x is less than 5, or x was greater than a 5. So this is how you come up with these two inequalities that you solve. You subtract 5 from both sides of the equation, x plus 5 from both sides of the inequality, less than or equal to 10 minus 5. X is less than or equal to 5. Or x plus 5 minus 5 greater than or equal to negative 10. We're going to subtract 5 from both sides of that inequality. And we end up with x greater than or equal to a negative 15. And I think, okay, that doesn't look right because 5 is 5 units, negative 15 is a distance of 15 units. But we're not just talking about the absolute value of x. We're talking about the absolute value of an expression. So when you have the absolute value of an expression here, these are not going to be the same number. This is our dumbbell here, so our x is going to be in the middle. X has to be, you can start with the smallest number, negative 15. It's less than or equal to x, which is less than or equal to 5. Or you can think x is in the middle, and he's greater than or equal to this smallest number, but he's less than or equal to the larger number. This is the solution. Remember we said that if you have less than, or if you have less than or equal to, what were these? These are conjunctions. They're and statements. Okay, these are and statements. Now, I'm going to not redo this video. Hear me carefully. These conditions are made. But we're going to we had to solve these two inequalities, x plus 5 less than or equal to 10, x plus 5 greater than or equal to 10. We solved them both. And both of those conditions have to be met. I misspoke when I put that or there. Reprogram your mind here. We do have to show two different inequalities here that we solve, but x has to meet both of these conditions at the same time. Please text me if I've confused you on that. I'm not going to take the time to redo the video, just like I can't rewind to class. So we have conjunctions. This is a conjunction. They are and statements. And they have the barbell looking graph, and it is a compound inequality. Compound inequalities you combine into a three-part expression. You've got a number less than or equal to x less than or equal to another number. Okay? Conjunction, because it's less than. That means it's all of that inner part right there. You have to fulfill both parts of this inequality at the same time. You write it as a compound inequality here. Lots of weird vocabulary, gets sort of old really fast. Play with these, pay attention to them until, write them and write them and write them, work with them. If you look on your text on page 206, there's a chart in the middle. It says comparison of the two types of absolute value inequalities. Maybe some of you will find this helpful. I'd like all of you to look at it, but if it just fries your brain, don't worry about it. They're trying to condense into some straight mathematical language what we figured out by thinking about what absolute value really is, where absolute value is just the distance from 0. So let's go ahead and see what we have next. Solve the absolute value of negative 3x plus 6 is greater than 18. The absolute value of negative 3x plus 6 is greater than the absolute value of 16. I'm going to have to split this up two ways to solve this absolute value inequality. The first is exactly what we have. Negative 3x plus 6 greater than 16. We also have negative 3x plus 6 less than a negative 16. We saw that just a few moments ago that when we're talking about a distance greater than 16 on the number line, what's that mean? Well, the distance is greater than, it's going to be one of these things that looks sort of like this, where we're moving out in opposite direction on the number line. Only one of those has to be true, so this is what we call a disjunction. It's the union. As long as one is true, the whole expression is true. That's written very horribly. Or, now we're going to solve this. If we subtract 6 from both sides of the inequality, we have negative 3x is greater than 10, and that just doesn't seem right. Okay, let me go ahead and keep this. This is very similar to the example we have in the book, but they've got an 18. So we're just going to go ahead and keep negative 3x plus 6 greater than 16. We subtract 6 from both sides of the equation. Now we have to divide both sides by a negative 3. What happens when you divide by a negative number? The direction of the inequality symbol changes. So you have x is greater than negative 10/3. Okay. X is greater than a negative 10/3. Now, let's see what we have over here. We're going to subtract 6 from both sides of the inequality. Negative 3x plus 6 minus 6 is less than negative 16. Negative 3 minus 6. Negative 3x is less than negative 6 and 6 is 12. Negative 22. We're dividing both sides by a negative 3, which changes the direction of the inequality, and we have x is greater than 22/3. Negative divided by negative is positive. We change the direction of the inequality. Do you see what we did over here? I said, you change the direction of the inequality, but I didn't write it, now did I? How many of you caught that? When you multiply or divide by a negative number, when you are working with inequalities, the direction of that inequality symbol itself must change. So let's go ahead and graph this on a number line and see if we get something that looks correct. Well, we have 0. We have, oh, maybe negative 10/3. Maybe a positive 22/3, which is about twice as far. Has to be less than negative 10/3. Has to be greater than 22/3. So what is your solution? X is less than negative 10/3, or X is greater than 22/3. X is less than negative 10/3, or X is greater than 22/3. When you have absolute value inequalities that involve greater than or greater than or equal to, these are called disjunctions. They have or, which means as long, they only have to fulfill one condition. And their graphs are going to go out in opposite directions. And you're going to have to write both inequalities, because there's no way that a number can be less than negative 10/3 and greater than 22/3 at the same time. Take your time on 5.7, work through them, work through all your problems. Give me a text if you have difficulty, and I know that you can do it. I look forward to being with you next time.